This is Math 1's 2025 Spring Practice Final. Let's dive in. Number 1, we're trying to solve the inequality. Remember that whenever we have our variable on the left-hand side, this usually is an arrow that points the direction that you're going to be going. We're obviously going to be pointing to the left, which immediately eliminates option B. We also know that there's no equal to sign underneath, which means we have an open circle. This one is a closed circle. These two are open, or these three are open circles. That eliminates D because we have a closed circle. And finally, we have to choose between C and A. There's no reason for there to be a positive 6. We are clearly dealing with a negative 6. The correct answer is indeed A. In number 2, the variable's on the left or on the right-hand side, and typically we put the variable on the left-hand side. So in this case, I'm going to switch the A to be on the right, the A to be on the left, the 0 to be on the right. Whenever you switch these two symbols from what we used to have, we have to flip this sign as well. So instead of having a less than or equal to, we now have a greater than or equal to. And again, we kind of do the same thing. Now that the variable's on the left, this arrow is saying we go to the right, and that is between C and D. We have eliminated A and B. And I need to be an equal to, I need a closed point. Therefore, the correct answer here is D. And indeed, I am greater than or equal to 0. All right, moving on to number 3. I don't have my inequality solved for my variable n. I have it solved for negative n, so I need to get rid of this negative. There's 2 ways to get rid of a negative. The first way is to divide both sides by -1. Another way is to multiply both sides by -1. I am just going to divide by -1. That's what most students will do because they see this as a -1 times an n, and the opposite of multiply by -1 is divide, right? So divide by -1, divide by -1, both of them are fine. Whenever we multiply or divide by a negative, we are always going to flip this sign, and it becomes a less than or equal to. And then I have a positive n over here because a negative divided by a negative is a positive, which is the whole point. We got n by itself, and a positive divided by a negative is a negative. So we have a -6 on the right-hand side. So I need to have an arrow that goes to the left, and it needs to go from -6 with a closed point. So that's going to be option A. In number 4, we're trying to solve the inequality. Remember that when you're solving inequalities, it's basically like solving an equation with only one extra trick. If you multiply or divide by a negative, this sign flips. So what is being done to n? N is being added by 5. The opposite of add 5 is to subtract 5. Whatever I do to the left, I also do to the right. When I subtract 5 from both sides, the 5s are gone, leaving behind just an n. Let me rewrite that n down here. And I'm not multiplying or dividing by a negative. I'm going to keep this sign the same. It's still a less than or equal to, and a -13 and a -5. Remember, these signs are going the same direction. Therefore, these two numbers are added, and we are still in the negative direction. So this is going to be a -18, and that is going to be option D. In number 5, we are trying to undo this multiplication by -20. Again, when there's no sign, no symbol in between your coefficient and your variable, then we are multiplying. So this really says -20 times b. The opposite of times by -20 is to divide by -20. Divide by -20 on both sides. Remember that whenever you multiply or divide by a negative, we're going to flip this sign. Instead of being a greater than, we are now a less than. And these 20s are going to cross cancel, leaving behind just your b. And then how do you do 340 divided by -20? Well, first, a positive divided by a negative is a negative. And then next, I can cross off each of these zeros and say, what is half of 34? Because 34 divided by 2 is half of 34, and that's just 17. The correct answer here is B. Moving on to number 6. In number 6, I need to either get rid of this -10 or get rid of this 2. Just in terms of PEMDAS, if I add 10, it's technically -10 over 2, so it's easier to just get rid of this 2 first. The way that we get rid of the 2 is by multiplying both sides by 2. When we multiply both sides by 2, watch what happens. The 2's and 2's cross cancel, leaving behind this v minus 10. And I have not multiplied or divided by a negative, so I keep this sign the same. It's still a greater than or equal to, and now I have to multiply my 7 times my 2, which is going to be a -14. And finally, I need to get v by itself. To isolate my variable, I'm going to undo -10. I'm going to add 10 to both sides. When I add 10 to both sides, that does eliminate my 10, leaving behind our variable, and I have not multiplied or divided by negative. The sign stays the same. It's still a greater than or equal to. These two numbers are opposites of each other. That's a positive, that's a negative. Whenever these two signs don't match, you are subtracting and taking the sign of the larger. So subtracting 14 and 10 gives us 4. Take the sign of the larger, and it's a -4. The correct answer here is C. Moving on to number 7. we have some parentheses. Whenever you have nothing in between your parentheses and even a sign or a number, we are going to distribute that sign or number. So technically, I think about this as like a -1, and I'm going to distribute into both of these. Let's go ahead and draw that with ink. So after that distribution, the 21 stays behind, the less than or equal to stays behind. I have not done anything to both sides. I'm just working on one side. I now have a -x and a +10. I need to solve for x. I'm going to subtract 10 on both sides, giving us an 11 on the left-hand side and a -x on the right-hand side. I still need to get rid of a negative. A lot of students will divide by -1. You can do that, that's correct. I'm going to multiply by -1 to show you that you can do it this way as well. Whenever you multiply a negative by a negative, you get a positive, and therefore we get an x by itself. Remember, anytime you multiply or divide by a negative, this sign will flip, and now it is a greater than or equal to, and now I have a -11 on the left-hand side. While this answer is correct, it is not in the multiple choice answers. All of these multiple choice answers have an x on the left, so we need to put our x on the left as well. When we put the x on the left, that means the -11 is on the right, and whenever we switch the sides, this sign also will switch from a greater than or equal to a less than or equal to, and our correct answer is going to be B. In number 8, we have to distribute our 5 first into both of these two terms. You distribute whenever these two terms on the inside cannot be combined, and you are mixing multiplication with either addition or subtraction. So 5 times 4 is going to be 20. 5 times -n is -5n, and I'm going to copy down the -3n as well, and I'm going to copy down the left-hand side of our inequality. From here, I'm going to combine my like terms, and notice we have a variable and the same variable with the same power and same power. So -5n and -3n are going in the same direction. They're both going to a -8n. I still have the 20 on the right-hand side and 84 on the left-hand side with this less than or equal to. Zooming into our problem now, we need to reserve one side for variables and one side for constants. Because I only have one variable on the right-hand side, I'm going to designate the right-hand side for my variables, which means this 20 is a constant and belongs on the other side. So let's subtract 20 on both sides of my inequality, and that's going to cancel out my 20, leaving behind a 64 on the left-hand side, still have a less than or equal to, and I have a -8n on the right-hand side. I need to get rid of this -8, which is being multiplied by the n. The opposite of, or the inverse operation of multiplying by a -8 is to divide by a -8. Dividing both sides by a -8 results with a sign change, or this sign right here will change because we are multiplying by, or dividing by a negative in this case. So we have a greater than or equal to, n is going to be on the right hand side, and I have a positive divided by a negative, which is a negative, and 64 divided by 8, which is 8. I'm noticing that all of my answers have an n on the left-hand side, so I'm going to put my n on the left-hand side as well. When I do that, n goes on the left, -8 goes on the right. Whenever we switch these two, we switch the sign in between as well. This is going to be a less than or equal to, and less than or equal to -8 is option C. Moving on to number 9. Again, I have some distribution. Let's go ahead and distribute 2 times 6k is going to be a 12k. I have a feeling I'm going to forget about the 4k, so let's write that down as well. 4k is going to be added with that 12k because that sign is still going to be carried down. And I'm going to distribute now the 2 times the -4 to get a -8. Copy down the inequality symbol and distribute yet again. 3 times 8 is going to be a 24, and 3 times another 8k is a 24k. From here, we are going to combine like terms. I'm noticing that these k's, and I guess that's the only thing that can be combined. I have a 16k on the left-hand side with a -8. Copy down everything else as well. 24 plus 24k. I have to reserve one side for the variables and one side for the constants. I happen to see that all of my variables should stay on the left-hand side, so I'm going to reserve the left-hand side for my variables, which means I need to move my variables to the left-hand side. The way that we do that is by doing the inverse of whatever this operation is. In this case, I'm going to subtract 24k on both sides, subtract 24k on both sides. You're allowed to do two operations at the same time. If I know that the left side is for my variables, my right side must be for my constants. 24 is a constant. This -8 is a constant, which needs to move over. The way we're going to move it is by doing the inverse of -8, and we are going to add 8. So add 8, add 8. Those get canceled out. These get canceled out, and we're left with what? Okay, 16 minus 24. These are opposites, right? That's a positive, that's a negative, so we're going to subtract to get 8. And then we take the sign of the larger. I can write my 8s correctly. The sign of the larger is a negative, so it's going to be -8k. And did I multiply or divide? No, so I don't have to worry about flipping the sign. It's still a greater than or equal to. And 24 plus 8 is a 32. From here, I'm going to divide both sides by a -8. Divide by -8. Divide by -8. And that will cancel out. Remember, whenever you multiply or divide by a negative, this sign will flip to a less than or equal to in this case. And I still have my k on the left. And this is going to be a -4 on the right. K less than or equal to -4 is going to be option A. Moving on to number 10, compound inequalities. So there's technically two ways to solve compound inequalities. The official way that you're supposed to do it is to solve this compound or this inequality, and then you do a second problem where you're going to solve this inequality. Luckily, we can solve them both the same way, so I can just do them all in one go. And I'll probably do this way for the final as well. In this case, I'm just going to get rid of this +7 to get my variable isolated. I'm going to do that to all three sides. So I'm going to subtract 7, subtract 7, subtract 7. And I ran out of room, so I'm going to do it down here. I'm going to say -3 is less than n, which is less than or equal to 9. And that is option C, just based on my numbers that I'm looking at. If you had something more difficult, or maybe I had something over here was 2n, then that would not work because now I have an imbalance of 2n and n, but I don't think I'm going to put those on the final for you guys, just so you know how to solve them in the future if you see those. All right, number 11, we have another compound inequality, this one separated with an or. The way we solve these is to ignore all of that and just solve this inequality. We'll come back and then solve this second inequality. So for this first inequality, my variables are clearly on the left-hand side. Let's move the constants to the right-hand side by subtracting 6 on both sides. Subtracting 6 gives us a 9n is less than or equal to a -54, and then from there we'll divide by 9 to give us n is less than or equal to 6, -6, because a negative divided by a positive is a negative. So there's one of my answers when I can clearly see, oh, look, they're doing some of those. In fact, just with that one operation, I can look at my multiple choice and say that is actually incorrect because it's missing the equal to sign, which eliminates B, A, and D in one step. The correct answer is C. It's the one that had the less than or equal to -6. I can check this one as well if I wanted to, just to show you how to do math. I will do that. Let's go ahead and subtract 8. I'm going to get -3n is less than or equal to 6. Then from there, I'm going to divide by -3, divide by -3, and n is going to be greater than or equal to, again, this sign flip because we divide by a negative, and I have a -2, and hey, that's exactly what we had for option C. Number 12, absolute values. So the way that absolute values work, as a reminder, is it's a distance away from 0. So let's go ahead and tell a quick story to make sure that everyone understands this. Let's go ahead and call this stuff on the inside without the absolute value. We'll name him Bob. Here's how absolute values works. It's distance from 0. So if I go 1, 2, 3 to the right, that's where Bob lives. If I go 1, 2, 3 to the left, that's also where Bob could theoretically live, because we know that the absolute value is the distance from 0. And we happen to know that Bob is, in this case, 1 away from 0. So maybe, I don't know why I did 3 lines there. Let's go ahead and say that is just 1 distance away. So Bob could live at 1, or Bob could live at -1, because both of those are 1 unit away from 0. Just as a note, when you get to higher levels of maths, sometimes you have to do the lateral direction or the imaginary direction, and you could have 4 locations for Bob. And when you do higher dimensional analysis, you could have multiple dimensions because those are all a distance of 1 away from 0. Luckily, we only have 2 different directions to go from 0. We have just 1 and -1. So Bob could be here or Bob could be here. So that's what we'll say. We could say that -9 plus x, aka Bob, remember Bob is just -9 plus x, that could be -1 because it could be right there, right? Or I could say that Bob, -9 plus x, could be this one right here. It could be 1. And that's how we get rid of the absolute value. As a procedural rule, you can just drop it and make one of them positive, and then you can drop the absolute value and make one of them negative. That's just generally how it worked with real numbers. With complex numbers, it's a little bit more complex, haha, pun intended, where you now have to do 4 different operations. For both of these equations, we are just going to solve them. And usually they're solved exactly the same way because you will never, ever, ever touch the inside of this. A lot of students make the mistake of saying, well, it's a positive 9 because absolute value means everything on the inside is positive. No, that is wrong. That is a misconception. From here, I'm going to add 9 to both sides, and look on this one, I can add 9 to both sides on this one as well. However, my answers will be different. I'll have an 8 in this case, but I'll have a 10 in this case. So 8 and 10 will be my answers. The way that we list them, we just list 2 different answers in no particular order, and you can say the option C is correct. For number 13, we'll go a little bit faster. Remember, we need to isolate our absolute value first, so we need to get rid of -2. The most common mistake with this type of problem is thinking that you can distribute into the absolute value symbols. You cannot do that. You need to first get rid of this -2 that is being multiplied. The opposite or the inverse operation of multiply by -2 is to divide by -2. When I divide both sides by -2, I'm left with the absolute value of x minus 3 by itself is equal to a positive 3. Just as a note, if this had been equal to a -3, you can never have an absolute value by itself equaling a negative, and you could stop right right there and say there are no solutions. That one might show up on the final, so be ready for it. Now we can drop the absolute value symbol and we can turn this into two separate problems. The first problem is x minus 3 is equal to 3. The second problem is x minus 3 is equal to a negative 3. From here, we're going to solve both of these the exact same way by adding 3 to both sides. When we do that, we get x is equal to 6 and x is equal to 0. So 6 and 0 are the correct answers, therefore option D. And just as another note, you don't have to know how to solve these if you're really good at test taking skills. If you plug in 0 into this x, you say, 0 minus 3 is negative 3. The absolute value of negative 3 is positive 3, and positive 3 times negative 2 is negative 6. And oh look, negative 6 is equal to negative 6, which means 0 is an answer. Just by plugging in 0, you have eliminated every single one of these options by guess and check. So as a general strategy on this final, because it is all multiple choice, guess and check is now enabled. Nice and easy. All right, number 14, let's show you how to do the math instead of just guess and check, because that's a lot of guessing and checking. The general idea is we want to isolate the absolute value, so we need to get rid of this 10 minus 9. Two very common mistakes here. Again, one of them is thinking that I can distribute the negative 9, which you can never do. The other most common mistake is thinking you can do 10 minus 9 to turn it into a 1. That doesn't work because of orders of operations. You must first multiply and then you can subtract. And because I cannot multiply, I cannot distribute, you are forced to just undo the stuff that is happening to the left. Here's how you do that with reverse PEMDAS. Starting with PEMDAS at the bottom, subtraction and addition, I can subtract 10 on both sides. When I subtract 10 on both sides, I'm left with negative 9 times the absolute value of 3p minus 4, and the absolute value is equal to a negative 117. From here, I'm going to divide both sides by negative 9, and I'm going to get the absolute value of 3p minus 4, and absolute value is equal to, this is going to be positive, which is a good sign because negative divided by negative is a positive, and if this was a negative, the answer would be no solutions. But it is a positive, so we can continue this on. This is a hard problem to do. The first thing I'm going to see is I'm going to make them both positive, so I don't have to worry about that. This is how I do this problem in my head. I think of 117 divided by 9 is really something divided by 9 plus something else divided by 9, because I can combine these both into one single divided by 9. What's an easier number to divide than 117? Well, 90 is really easy to divide because 90 divided by 9 is 10. Well, now what plus 90, this is the what plus 90 equals 117. Well, 27 plus 90 equals 117, and 27 divided by 9 is 3. So, and I can just copy down this plus sign, copy down the 3, plus 3. Therefore, the answer to this problem is 10 plus 3, which is just 13. And then from here, I can drop the absolute value symbol and turn this into two separate problems. I can have 3p minus 4 is equal to a positive 13, and I can have a 3p minus 4 is equal to a negative 13. And that's not how I write a negative 13. Let me try that again. There we go. Each of these are going to be solved the exact same way. Add 4 to both sides as your first step. When you do that, you're left with 3p is equal to 17, or 3p is equal to a negative 9. Then again, solve them by dividing both sides by 3. When I divide both sides by 3, I'm left with p is equal to 17 thirds, which is an irreducible fraction. Since these two numbers are co-prime, you can't divide them by anything. And this is going to be p is equal to a negative 3. We're looking for a negative 3 and a 17 thirds. A negative 3 and a 17 thirds means we're dealing with option B. Moving on to number 15, we're supposed to graph each line. So when you're graphing the lines, remember that I'm always going to be giving you slope-intercept form on this final, which saddens me a little bit because there are 3 forms. We didn't even get to my favorite, which is point-slope form. But in the slope-intercept form, we have y is equal to mx plus b, where m is the slope and b is the y-intercept. Usually the y-intercept is the easiest because it's where it crosses the y-axis, so I should be crossing at positive 5. Does this one cross at 5? Yes, it's in the running. What about B? Doesn't cross at 5? Not an option. What about C? Does it cross at 5? No, it crosses at like a little bit above 2 but below 3. Therefore C is out of the running. And D doesn't go through 5 either. You didn't even need to know the slope. You just need to know that the y-intercept was 5 to get this answer correct. But just as a general reminder, my slope that I swear I can spell correctly is usually a fraction, and that fraction is the change of y divided by the change of x. And some people prefer to call that the rise over the run. All right, and let's move on to number 16. Oh, this one is also in slope-intercept form, except I hid what the b was. Did you know this is the same thing as plus 0? I bet you did. And this 0 is the y-intercept. So that means I should be crossing the y-axis at 0. So if the y-axis is 0, crosses 0, crosses at 0, crosses at 0, all we've done is we've eliminated a. So now we need to know how to do slope. Remember that the slope is the number, usually a fraction, in front of your x. And slope is always going to be the change of y divided by the change of x. If you prefer the definition of rise over run, that's okay as well. I prefer y over x because this is how much up and down I move versus how much left and right I move. This is telling me 5 up, 3 right. And I will write that here. Go 3 to the right, go 5 up. So from 0, from the y-intercept, I'm going to go 5 up, 3 right. Let's check. From 0, oh, that's out of the running. From 0, I go 5 up, 3 right. Okay, that wasn't there. It's not B. I should be going from 0, I should go 5 up, 3 right. C is eliminated. From D, I should be going 5 up, 3 right. And indeed, D is the answer. Moving on to number 17. This one is almost the same thing, except this time we're attaching an inequality as opposed to an equal to sign, which just means we need to determine if it's supposed to be a dashed line or a solid line and make sure that we're shading correctly as well. So let's make sure that the line first is graphed. Remember that I have a number in front of the x. Even if you can't see one, there is always a number in front of the x. So technically, the number in front of x is 1 divided by 1, which is just 1, and 1 times x is just x. That's why it's a hidden 1 over 1. Therefore, the slope goes up 1, right 1, up 1, right 1. The y-intercept should be -2. Let's check the y-intercept first. So for each of these, we should have a y-intercept of -2. So y-intercept of -2, good. Y-intercept of -2, bad. Y-intercept of -2, good. Y-intercept of -2, good. So we've only eliminated b from the y-intercept. The next thing I need to check is to make sure that I have the slope correct. I should be going up 1, right 1. They're both positive. If this was a negative, it would be down 1, right 1. Usually, if there is a negative, I always attach it to the top, and I leave the bottom always positive, which means you're always moving to the right, because we read from left to the right. All right, so up 1, right 1. Let's see, right over here. Up 1, right 1, up 1, right 1 seems to be going good so far. Up 1, right 1. No, this one is going down 1, right 1, so that one is incorrect. C, eliminated. What about D? D should be going up 1, right 1, up 1, right 1. This one is going down 1, right 1, which means D is out of the running. Just based on slope alone, A is the correct answer. But I do want to teach you a little bit more, making sure you have 2 facts. Maybe I can teach them in 18. Just very quickly, if you don't have an equal to sign under here, it is a dashed line. I'll teach you that one new thing. Okay, let's see if 18 teaches some things. Number 18, let's check the y-intercept. Should be -1, -1. Nope, wrong y-intercept. Y-intercept of -1, good. Y-intercept of -1, bad. C is eliminated. Y-intercept, good. Okay, so both D and B have the correct y-intercept. And the slope here should be up 3, right 2. Let's see. Up 3, right, well, let's see, up 3, right 2. No, so just based on slope, I can see that D is the correct answer because it goes up 1, 2, 3, right, 1, 2, and that is the correct slope. So you don't even need to know how to do the shading, but let me teach you how to do the shading just in case knowing slope intercept form is not enough. To do shading for slope intercept form, whenever you have a greater than or a greater than or equal to symbol, the top portion should be shaded and the bottom portion should not be shaded. So notice this was a greater than, therefore the top should be shaded, and look, the top was shaded. If you're ever confused, if you have something harder, maybe you have slope, or maybe you have point slope form, maybe you have standard form, some other form of a line, what's usually the best option is to find a point that's not on the line. Usually I choose the origin 0, 0. You plug in x is equal to 0, you plug in y is equal to 0, and see if it works. See if that inequality holds. If it does hold, then that point that you randomly chose is in the solution, and that section should be shaded. If you chose a point that makes this solution like 1 is greater than negative, or you say like 1 is greater than 2, well, obviously that's wrong, right? That would mean that the point that you chose does not work. All right, moving on to number 19. We're going to solve this one by graphing. So for this one, since you've made it this far in the video, I might as well just tell you some cool tricks. You don't have to solve it by graphing. It's multiple choice. You can go ahead and graph it, or you could solve it with elimination. You could solve it with substitution, whatever floats your boat or sinks your sub for this one. I am going to look at your work to see if you're able to do it. But for this year, I'm purely basing it off of the multiple choice, which means you could totally solve this whatever method you want. I'm going to solve it by graphing because I like to teach. That's the whole point. I'm a teacher. All right, so for this first equation, y-intercept of 3, y-intercept of 3. And then from there, I'm going to go up 2, right 3, up 2, right 3, and I've run out. I can also go down 2. I can go down 2, left 3. And I can connect those with a line and continue it out, right? This next one is going to have a y-intercept of -4, so go down to -4. We have our y-intercept, and I'm going to go down 5. Again, when I have a negative, I usually put it in the top. I think of this as a -5. So I'm going to go down 5 and then right 3, which is going to go off the graph, because if I go down 1, 2, 3, 4, 5, it's way off the graph. So instead, I'm going to cheat. Well, it's not really cheat. I'm going to put the negative in the bottom instead of the top. You're allowed to put the negative in the top or the bottom, whatever floats your boat or sinks your sub, right? So this is now going to say 5 up and then left 3. So 5 up and left 3. So 5, 1, 2, 3, 4, 5 up, and left 1, 2, 3 is that same point that we already had. I'll just circle that and say this line goes through that point. Therefore, the correct answer is this -3, 1. -3, 1 is option A. What about for number 20? Again, I want to show you how to graph this, but you don't have to solve it by graphing on the actual final. Y-intercept of -3, y-intercept of -3. From there, I'm going to have a slope that is 2, but you're saying to yourself, that's not a fraction. Well, 2 is the same thing as 2 over 1, which means you're going to go up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And you can also go left 1, down 2, and you can connect all of these with a line. Let's do the next one. We have a y-intercept of 2, y-intercept of 2. From there, I'm going to go 1 up, 3 right. Let's see, 1 up, 3 right, and oh, look, we have another point in common. And I can also do the reverse. I can go 3 left, 1 down, and I can say that is also a point on the graph, and I can connect those with a line. The correct answer is where we cross 3, 3. 3, 3 is option D. Moving on to number 21. Solve by substitution. Substitution means we're taking one variable that's been solved for. Luckily, we have one already. And we're putting all this -5x minus 2 in for y, which means -5x minus 2 is this y. I'm going to rewrite this bottom equation, but instead of writing a y, I'm going to write all of this in right here. Here we go. I have 4x plus 7y is equal to 17. Can you see? I've rewritten everything, given myself space for the y. What's in that y? This -5x minus 2 is the y. So I'm going to say -5x minus 2 here, and then let's go ahead and solve. Notice that I had two equations with two types of variables. Now I have one equation with one type of variable. And let's solve. We have distribution. First, let me rewrite my 4x before I forget about them. And distribution, 7 times -5x is a -35x. And then I have 7 times a -2, which is a -14. And all this is still equal to 17. I'm going to combine my like terms. I'm seeing these two are my like terms. This is going to be a -31x. Copy down my -14 is equal to my 17. And now that I have the left side simplified, let's say that the left side is my variables, which means this constant needs to go on the right side for my constant side on my right side. I'm going to add 14 to both sides, add 14 to both sides. And when I do that, I have a -31x is equal to 31. And then from there, I'm going to divide both sides by -31, divide by -31, and x is equal to a -1. That's 1/2 of my answer. Remember, I should have an x coordinate and a y coordinate. -1 for my x coordinate, however, does leave just option C. I like to teach, so let me show you what you would do next in case maybe this one was a -1 too. How do you choose between -3 and +3? I don't know. Well, you'd plug in -1 in for either this x or for this x. I would choose this one because it's a little bit easier. I would say, okay, I have this equation, which I'm going to recopy down. It's y is equal to -5x minus 2. Do you know what x is? Well, I do. X is -1. Let's plug it in up here. -1 is plugged in right here, and then I can simplify this. I can say y is now equal to -5 times -1, which is a +5, and +5 minus 2 is 3, and therefore the y coordinate should be 3. Putting these two together gives you your x and y coordinate, just like you did back here when you were graphing. You need both an x coordinate and a y coordinate to figure out what this point was supposed to be. All right, let's do number 22. So this one is elimination again. No, this one is substitution. I apologize. Substitution means we want to have one variable that we solve for. Notice that in the last problem we had the y solved for. In this equation, none of these variables are solved for. So I can either solve for that x, that y, that x, or that y. This one is going to be easier because it doesn't have a number in front, which is going to save us a step. So let's solve for this y. That'll be fastest. Let's move this 2x to this side. The way that I would do that is I would add 2x to both sides. When I do that, I'm going to get y by itself. The right side is going to be -7 plus 2x. Now that I have my one variable solved for, I can say if y is -7 plus 2x, this y right here is also -7 plus 2x. So let me rewrite this equation. Here I go. I'm going to say -6x plus 3y is equal to 4. And guess what plugs into the y? This negative 7 plus 2x. And now I have one equation with one type of variable. And then from here I can distribute, right? So positive 3 times negative 7 is negative 21, and positive 3 times 2x is a positive 6x. And rewrite everything else. I have a 4 over here on the right and a negative 6x on the left. Now I'm going to combine like terms. I'm noticing that I have a negative 6x and a positive 6x. They cancel out. So I just have negative 21 is equal to 4, which is bad. You can't ever say that two numbers that are not the same are the same. Therefore, this is no solution. Let's go ahead and play the what if game. So here's the what if game. What if I had a number like 1 is equal to 1? Then the answer would be infinite solutions. There's only 3 scenarios. You'll either have a number equal to itself, a number equal to the wrong number, or an actual one variable is equal to a one number. Those are the only 3 scenarios that will happen. In this case, we had no solutions. The correct answer here is A. All right, moving on to number 23. Solving by elimination. Elimination is a fancy way of saying you're going to either add or subtract these equations. If you need to manipulate them, you can. In this first case, we don't need to. Watch what happens if we add both of these equations. If we add them, negative 2y and plus 2y are opposites of each other, and they will be eliminated, thus the name elimination. So now we're going to do the x's. Negative 9x plus 3x is a negative 6x. And then finally, I have a 19 plus a negative 1, which is a negative 18 after adding them together. And then from here, we're going to divide both by negative 6 on both sides, and I'll get x is equal to a positive 3. Lucky here, I got two positive 3's, so I have to do the next step. I need to plug my positive 3 back into either this x or this x. This one looks easier. There's slightly smaller numbers. It doesn't really matter in this case. You can plug them into either equation. So I'm going to say 3x plus 2y is equal to negative 1. My x is 3. I just got that from the last step. So I can say 3 times 3, which is just 9. So 9 plus 2y is equal to negative 1. And then from there, let's subtract 9. Subtract 9, subtract 9. So I get 2y is now equal to a negative 10. And then let's divide by 2, divide by 2. So y is equal to a negative 5. So y has to be negative 5. And that is not an answer. So I've done something wrong. What have I done wrong? Let's see. Did I copy down my equation correct? 3x plus 2y is equal to negative 1. 3x plus 2y is equal to negative 1. That's correct. Plugged in 3 into the x. 3 times 3 is 9 plus a 2y. So far, so good. I have to subtract a 9, subtract a 9. I got a negative 10. Interesting. Maybe I made a mistake back here. Maybe it was a negative 3 instead of a positive 3. Let's go through the math once again. Yep, that's where I made the mistake. That was very silly of me. Okay, so in my very first step, I said that negative 9x plus 3x is negative 6x. That was correct. And I also said that 19 plus a negative 1 was a negative 18. I took the sign of the smaller number. I'm supposed to take the sign of the larger number. The larger number here is not a negative. It should have been a positive. So I should have come back up here and erased that negative. And now I have a positive divided by a negative, which is a negative. And if that's a negative here. And if that's a negative there, then it's a negative here. And then if that's a negative, the opposite of a negative is not a negative, it's a positive. I should have just left that sign and said positive. And then if that's a positive, then I would come back down here and get an entirely different number. And I would say 9 minus 1 is 8. And if I do 8 divided by 2, I get a 4. So I should have a y-coordinate of an x-coordinate of negative 3 and a y-coordinate of 4. So negative 3, 4. Negative 3, 4 is option A. And I just really, I like making mistakes because I get to talk about them to students. I noticed from the very end of my problem, I got 5 for my y-coordinate. I came back up and I said, none of those are 5. That means I made a mistake. Mr. Sindel does make mistakes. I am human. But usually I don't make mistakes when it comes to the final, when I make the final. If you got the same thing, if you found that, hey, none of those match, you have made a mistake. Go through the problem again. I went through the last half because I thought that's where I made my mistake. I ended up having to go to the very beginning because that's ended up where I made my mistake. Go back through your work and look carefully at each step to find those mistakes. That's how I find them, and that's how you should find them as well. Number 24. This one is interesting because I can't just add them together. If I add them together, these two are not opposites and these two are not opposites. But I can multiply this entire top number or the top equation by some constant. In this case, let's try to get rid of these x's. These x's I want to eliminate. Well, I need to have a negative 16 and a positive 16. Can I do something to that 8 to make a positive 16? Yes, I can multiply by 2. So if I multiply everything up here by 2, that's going to be a positive 16x plus 18y is equal to 2. Again, every single one of these numbers got multiplied by 2. So I'm totally going to ignore you now. I'm looking, okay, 16x minus 16x is 0. Okay, 18y minus 18y is 0. And 2 plus negative 2 is 0. 0 is equal to 0. Well, if it's the same number equal to the same number, that's infinite number of solutions. Kind of a fast one. I like those. All right, number 25. This one is the hardest one out of all of the elimination problems. Here's how you do it. So I need to have opposites. If this is a -5, that needs to be a +5. Oh no. If this is a 8, that needs to be a -8. Oh no. So I'm just going to go ahead and it's not really cross multiplication, but if I have a 5 down here, let's multiply it by a 5 up here. So I'm going to say 5 is going to be multiplied by that whole top equation, and 6 is going to be multiplied by that whole bottom equation. When I do that, I know I'm going to have a positive 30 and a negative 30. Therefore, they will be eliminated. Let's go ahead and rewrite those equations. I have a 30x plus 40y is equal to 110. And then for my bottom equation, I have negative 30x minus 60y is equal to negative 150. And now, when I add these two together, the x's will be eliminated, and I'll be left with a negative 20y is equal to negative 40. And then from there, I can divide both sides by a negative 20. And that's going to leave me with a y is equal to a positive 2. If y is equal to a positive 2, can we be done? We can be done. You could always plug this back in for either that x, that x, that x, or that x, any of those x's, to get the fact that you have to plug this y is equal to into any of these y's. I apologize. You have to plug the y's into the y values, any of those y's, and then you can figure out that, the x is indeed 1. Nice. You got lucky there. Let's do number 26. Solution to each system of inequalities. Okay. Right off the bat, I'm seeing that this is in slope-intercept form, which means I should have a y-intercept of a positive 3 somewhere. Positive 3. Well, no line goes through positive 3. A is eliminated. Let's go back to red. I should have a y-intercept of 3. Okay, that one's there. Y-intercept of 3. Okay, that's one's wrong. I should have a y-intercept of 3. Okay, that one's good. Okay, so both D and B have a y-intercept of 3, and they both look to be exactly the same line. They seem to have a slope of right 1 up 1, which means a slope of 1. Indeed, this hidden number in front of x is 1 over 1, or just 1. So that line is correct. What about this one? Whenever you have an x is equal to a number, this is always going to be a line that goes straight up and down through that number. So a line that goes straight up and down through -2. So a line that goes straight up and down through -2, a line that goes straight up and down through -2. And I'm noticing that both B and D are still correct answers. So the only difference between those two is what region is shaded, to the right or to the left. I noticed that both of them are shaded to the bottom portion of this diagonal line. So this diagonal line right here is not really going to affect us, and it makes sense. Like less than or equal to means underneath. So it is underneath. This is saying x has to be greater than -2. Just read that symbol out loud and you'll get the right answer. Greater than -2 means go to the right of that value. So if I'm going to the right of this line over here, right of the line means I'm talking about this section. The correct answer is B. Notice that D was going to the left of this line, which is the wrong direction. And then number 27, I have these two equations. Let's check the y-intercepts and see if any of these are going to be eliminated. Y-intercept of positive 3 and -1. Positive 3, -1. Positive 3, -1. Okay, well, B is eliminated. Positive 3, -1. Okay, C is eliminated based on y-intercepts. Positive 3, -1. Really, it's that easy? You just look at the y-intercepts, kids. It's that easy. Correct answer is A. I didn't even have to think about the fact that these both have to be dashed lines because there's no equal to. I didn't even have to think about shading in terms of what goes up, what goes down. I'm just noticing that the y-intercept of 3, this one, goes down because it's a less than, so anything that's underneath here is shaded. And then the one that has a y-intercept of -1 has to be greater than, it has to be shaded up above there. So yes, indeed, the shading is correct. And I'm looking at the time. I know that on the screen, in the very top left of your screen, way up there, it says 11:02. But my time, now that I'm in Atlanta, Georgia, recording this video. It's actually midnight and I have to wake up at 5 in the morning. I have to cut off the video there. I know there's a lot more to record. I will try recording it later. That's all I have for now. I'll see you guys later.